on the quiz review, the first set of directions tell you to use the properties of exponents to simplify. So all we're looking for here is, do you know when you're multiplying like bases that you add the exponents? Or do you know that when you're dividing like bases you subtract the exponents? Or if you have a power raised to a power that looks like this, that you know you're going to multiply the exponents. All right, and then simplify if you can. So in the first one, all I'm really looking for is, can you see that you have like bases? So the property says you keep the base, you have to add the exponents, 3/4 plus 1/2. You can use your calculator, but really that's just 2/4. So 3/4 plus 2/4 is 5/4. So remember, on your calculator, you can type 3 divided by 4 plus 1 divided by 2, hit your decimal, which would be 1.25, and then hit your math button, and that convert to fraction. And then that will get you 5/4. So it's 2 raised to the 5/4 power. When you're dividing like bases, you keep the base, you subtract the exponents. So I have 3 to the first divided by 3 to the 1/4. It's going to be 3 to the 1 minus 1/4 is 3 to the 3/4. And it doesn't say anything about putting them into radical form, you're just leaving them in exponential form. All right, when you get to 3, it's a little bit tougher because you, first of all, you have powers to powers that we can take care of. You have a negative exponent, and the other problem is you don't have the same base. So let's first take care of the power raised to a power, and we actually can take care of this negative exponent right away too. So I have 3 to the 3 times 1/5 is 3/5 times 9, 1/5 times 2 is 2/5. And then this 81 is raised to a negative power, so I'm going to bring that up, and it's 81 to the positive 2/5 power. Okay, so I took care of the negative, and I took care of the power raised to a power. Now I can't multiply those as is because they're not the same base. But I can get the 9 to have a base of 3 by saying 9 is 3 squared. I haven't changed anything. I'm still writing 9 raised to the 2/5. 81 is 3 to the 4th power. So I'm going to write 81 as 3 to the 4th raised to the 2/5. Again, I haven't changed anything. That's still 81 raised to the 2/5. So now I have a power raised to a power in both of these, so I'm going to multiply the exponents. 3 to the 4/5 and 3 to the 8/5. Again, all I'm doing is multiplying. 2 times 2/5, here I'm multiplying 4 times 2/5. And the last step then, because I'm multiplying and now they're all like bases, I keep the base, I have to add the exponents. 3/5 plus 4/5 is 7/5. 7/5 plus 8/5 is 15/5. That reduces to 3. 15 divided by 5 is 3. So 3 to the 3rd, 27. So again, just kind of recap what we did. We first just took care of the powers raised to a power. We took care of the negative exponent by bringing it up with the other two. Then we took care of getting the same base. We wrote 9 as 3 squared, 81 is 3 to the 4th. And then we had a power to a power again, so we multiplied the exponents. Then the rule said if you're multiplying like bases, you keep the base, add the exponents, and then we simplified. All right, so then let's get to number 4. A little bit easier than this. These are not like bases, nor can I get them to be the same base. So all I really can do is take 5 to the 1/3, raise it to the 3rd. So if I multiply those, I get 5 to the 1st, and then 7 to the 1/4 times 3, 7 to the 3/4. And I can't put those together. I definitely cannot get them to be the same base like in number 3. That's all I can do with that one. All right, in number 5, now these are not the same base, nor can I get them to be the same base. But what I can see is that really those, if I think about them as radicals, that's like the square root of 20 to the 1st over the square root of 5 to the 1st. And we've talked about that if they're both the same root, you can actually combine them together. So when I see 20 to the 1/2 divided by 5 to the 1/2, as long as they're both raised to the 1/2, it's like having the square root of 20 over the square root of 5. And I can simplify those. 20, as long as they're both under the square root, 20 divided by 5 is 4. So this reduces to 4 to the 1/2, or the square root of 4. If you want to think of it in radicals, that simplifies to the square root of 4. Now the square root of 4 is 2. Now I just have to take 2 to the 3rd power. So in a lot of these, if you can simplify what's in here first, I would do that. If you can't, then you could have taken 20 to the 3/2 and 5 to the 3/2, but again, we would have to see that it reduces, that since they're raised to the same power and you're dealing with the same root, you could simplify them. But a lot of times it's better if you try to simplify what's in there first. Now if this would have been 20 to the 1/3, couldn't have done that. But since they're both raised to the 1/2, I can simplify that. All right, number 6. 6, again, these are not the same base. They are not raised to the same power, technically, so I think what I would do on this one is I would raise them both to the 5th, a power to a power. So, and we also could take care of the negatives first. If you'd rather take care of the negatives first, you can do that. You can flip the 2 to the negative 2/5, bring it down to the denominator, or you can make this 3 to the positive 1/5 in the numerator. You can do that first. I'm going to do it second. So I'm going to do a power to a power.